New Hubble observations of the massive globular cluster NGC 2808 provide evidence that it has 3 generations of stars, instead of 1 as current theories predict.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Welcome to the Hubblecast. Globular clusters are the homesteaders of our Milky Way galaxy, because they were born during our galaxy's formation. They are compact swarms of typically hundreds of thousands of stars that are being held together by gravity. Now, astronomers have long thought that globular clusters experience a single baby boom of star formation at the beginning of their lives and then settle into a rather quiet existence. New observations by the NASA ESA Hubble Space Telescope is showing that this idea may be too simple. The Hubble analysis of the massive globular cluster NGC 2808 is providing evidence that instead of having one baby boom of star formation, starbirth went boom, 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 creating 3 generations of stars early on in the cluster's life.
We were really shocked by the results. I mean, when we saw for the first time the CMD, we said, wow! Because, I mean, we were not expecting anything like that. But the picture that we had in mind was that globular clusters were simple stellar systems, simple because they host stars which have been formed all together at the same time, from the same material, that is with the same composition, and stars which are all at the same distance. I think this is going to change our view of globular clusters, and of course, in this sense, it's a cornerstone result.
The astronomers used Hubble's advanced camera for surveys to measure the brightness, seen along this axis, and the colour of the cluster stars, seen here, with blue to the left and red to the right. The measurements showed 3 distinct populations, with each successive generation appearing slightly bluer. This colour difference suggests that successive generations contain a slightly different mix of some chemical elements.
We don't really know how it happened, but it may well be that the cluster form a first generation that can expel a lot of material that only later fall down, forming a second generation of stars with completely different chemical properties. That may be just an explanation and may be consistent with the fact that NGC 2808 is one of the most massive clusters in the galaxy, so able to retain all this gas.
Astronomers commonly believed that globular clusters produced only a single stellar generation, because the energy from that first batch of stars cleared out the remaining gas needed for more stars. But a hefty cluster like NGC 2808, which is 2 to 3 times more massive than typical globular clusters, may have enough gravity to hold on to that gas. Although the astronomers have searched only 2 globular clusters for multiple stellar generations, they say this may be a typical occurrence in other massive clusters as well. Now, no one is taking the radical step of suggesting that previous work on other clusters is no longer valid. But this discovery does show that the study of stellar populations in globular clusters may be heading in a new direction. The team plans to use ESA's Very Large Telescope in Chile to study the chemical composition of NGC 2808. This may offer further evidence that the stars were formed at different times, and it may yield clues as to how they formed. The team will also use Hubble to hunt for multiple generations in about 10 more hefty globular clusters. This is Dr. J signing off for the Hubblecast. Once again, you've guessed it, nature surprised us beyond our wildest imagination.